All right. So today we have my friend Sadegh Riazi. He is the CEO or co-founder of Pyte, which you can find at pyte.ai. That's Pyte. Tagline is data collaboration without the compromise. Also, they describe themselves as get the most out of your data partnerships by collaborating with always encrypted, noise-free data that never moves. And with that, welcome to the Data Exchange Podcast, Sadegh.
Awesome. Thank you so much for having me, Ben.
And full disclosure for our listeners, I am an angel investor in Pyte, but this won't be a vendor pitch. It will be a very informative conversation. So first off, just to set the baseline for our listeners, data collaboration, let's define what you mean by that. So my sense, Sadegh, is this can range from data enrichment to BI to ML, but you tell me, what do you mean by data collaboration?
Right. I mean, it's a broad term. It can be used in many different ways. Essentially, what we mean is that there are so many scenarios in which you don't have all the data that you need to accomplish your job. This could mean in marketing and advertisement, when you don't have, for example, when you are the advertiser, but you don't have the conversion data or vice versa. Or, for example, in healthcare, when you don't have all the necessary information that you need in financial services, especially for fraud detection. Or, for example, whenever you're training an AI model, it's rare that you have all the data that you need. Probably there are some obstacles internally within that organization, or you don't have, some good piece of data that is held by another company. So collectively, we call this kind of like data collaboration problem. Like when you need data where pieces are in different locations.
But the actual what you do with the data could be broad, right? So it could be just enrich my data, could be write a report, it could be build a model.
Correct. Yeah. I mean, you can pretty much with Pyte, you can do anything from like simple statistical analysis to executing SQL queries against a database to training and executing AI models. For example, for even LLMs. So all of that is possible. And where Pyte shines is where you don't have all of that data that you need for a variety of reasons.
So I can attest to this. Many, many moons ago, I worked in financial services, and the holy grail there was, think of yourself personally, listeners, right? So, it's highly unlikely that you have all your financial assets in one financial service company, right? So usually you use multiple banks, multiple brokerages, you have retirement accounts all over the place. So the holy grail is, how do I build a more complete picture of Ben, right? So of the customer. And that normally would involve some sort of data cooperation, which in a regulated industry like finance is, you have to be very, very kind of strict and careful about how you do that. And back in the day, it was kind of impossible to actually do and be compliant. So before we go more deep into how you folks do what you do, just to give a teaser to our listeners, since Sadegh, the hot topic now is generative AI and LLM, paint a scenario where data collaboration in that context might happen.
Right. It's actually a very hot topic for us. Like when you think about how you can either create, fine-tune, or use LLMs, there are so many privacy concerns. Let's say you're a legal firm and you want to just use one of these LLM-based services. Then the question is that, so are you essentially disclosing your client's data or some part of the legal contracts to an external firm? That has massive consequences. And what happens to kind of like data confidentiality? How is it managed? What if there's a breach? There's just so many challenges. And that's what we mean by do data collaboration without compromise. There shouldn't be compromise. You want to accomplish a goal where here is, answering your prompts in a way that you're paying to the service provider, but at the same time, you're not compromising on your own data confidentiality. So essentially, there could you can use Pyte in many different ways. One is that if there's a hosted LLM, with Pyte wrapper, you can answer your prompts without disclosing what is it that you asked and what was the result, which sounds a little bit counterintuitive, but it's actually possible thanks to secure computation technology. Or for example, when you want to start from some open source LLMs and you want to fine tune it based on your data. If you have all of the data that you need, then you can probably do it locally. But if you don't, then the question is that how are you going to exactly do that? If you have data across different organizations, or you want to collaborate with some other partners, then where is that training happening? Like who is sharing their data to which environment? And there's so many questions around that. We argue that all of this should happen over encrypted data. So you can fine tune. We actually have a blog post on this because secure computation is usually, has a high compute overhead reputation. We show that yes, there's overhead, but for many practical purposes, the overhead is completely acceptable. And we provided some benchmarks in that blog post for people to just.
So there's two pieces to what you just said, right? So there's the fine-tuning the model in kind of the secure way that you described. And, I could have a tolerance for, waiting, until tomorrow, right? So as long as you give me the endpoint, it's been fine-tuned securely, where I collaborated with another organization, I'm fine with that. What about the inference post fine-tuning? Is there still a need for secure computation then? After let's say, Sadegh, I've already fine-tuned where I collaborate with another company, I fine-tuned it's secure, and then now I'm doing inference, so I have the endpoint. So walk me through is there still a role for secure computation? And if there is it performant enough?
Great questions. Is there a role for secure computation? It depends who is the model owner and who is submitting the prompts. Like, for example, if you're a big organization and you have fine-tuned your model, you're hosting it internally, and then you're providing, access for your internal employees, maybe you can argue that, okay, so I can just do this in plain text, which is not a bad argument. However, what we think would happen is that there would be specialized companies that would have LLMs for a specific use case or for a specific niche. And then from that angle, they have spent a lot of time coming up with a superior model, and then there would be many customers that want to access that model from other companies. And there, yes, secure computation interface has a great meaning because you can keep prompts and the result confidential. Should it be applied to all types of prompts? I don't think so. I think there are sensitive prompts and less sensitive prompts. But when you're dealing with high value data, I think it's a good idea to run it over, secure computation.
How about latency and performance?
It depends on the size of the model. Like the performance if you're looking at real-time performance numbers, and the model is very, very big, and the performance in plain text is already kind of like borderline real-time, then adding secure compute overhead might be unacceptable. But it depends on the size of the.
Is it like 2x? So I'm just trying to kind of help the listeners think this through. So let's say I put the same prompt into ChatGPT. ChatGPT is not instant, right? So in ChatGPT, it takes 5 seconds. Will it take 10 seconds in this scenario?
Probably would take more, but it depends on your network connectivity and also how big the model is. Because if the model is smaller than a specific threshold, then the network latency itself might mask some of the secure compute overhead. But if you have a fast network and the model was super small to begin with, and you could get your answer in 1 millisecond, probably now it takes like 10 milliseconds, but you don't really feel the difference. Whereas if the answer was in 5 seconds and now it's like 15 seconds, that user experience might not be acceptable.
So I would be remiss if I don't press you to elaborate on this one thing you said earlier, because listeners may email me, which is this whole kind of almost science fiction like thing that you describe where I send a prompt, but somehow the prompt is disguised.
Right.
And so can you kind of unpack that a little bit in more plain language?
Sure.
What's an example?
Right. Let me explain how it's not done, and then I'll explain how it's done.
Okay.
So, there could be many different solutions to this problem. One solution is that, Pyte can act as a gate, as an intermediary. We receive prompts from companies, we remove PII or sensitive information, we submit the new prompt to, let's say, OpenAI. That's one option.
Which others do that, right? So
Yeah, there are companies that are doing this.
Yeah.
That's not our approach. We essentially, when we say that your prompt is not disclosed to whoever is hosting the LLM, it means that your prompt gets encrypted. And then thanks to Pyte software on the other side, you can run that encrypted data through LLM. The way that's not done is not equivalent to just like simply encrypting your prompt and asking your LLM model to still be intelligible. That's not how it works. Essentially, secure computation protocols require the entire computation to be described in a form that is, that is adhering to secure computation protocols. And that means that at the time of encryption, you're embedding that LLM functionality and then sending it over. And then from the other side, they're able to manipulate this prompt based on the model in a way that it gives you the same answer, even though they do not see the content, which is a little bit ironic and counterintuitive.
So it's almost like if you remove the language of embeddings, it's almost like I ask you a question in a garbled way, and then you're still able to answer my question.
Exactly. Yeah. I mean, that's essentially the unique thing about secure computation.
I see. Yeah.
And we're not injecting error. It has the same quality or accuracy as it had before, but it takes a little bit longer in exchange for full confidentiality.
Okay. And I imagine there's a lot of industries, use cases where this sort of capability in LLMs is starting to come up in your conversations.
It's starting to come up, yes. Yeah, I think, with the success of ChatGPT, there are obviously far more number of smart people that are working on this, coming up with new use cases. There are many new startups, even big tech players, they are coming up with better products and new products. So the space is becoming much bigger. And then as the space is becoming bigger, you see more kind of like security and privacy concerns just popping up.
All right. So this notion of data collaboration, right? So the classic term that people use here is the data clean room, right? So, and for our listeners who are not familiar with this term, it's basically, imagine two different organizations, right? So they're each coming with their own data, they come to an agreement, and then they form this data clean room, and inside that data clean room, they can collaborate, right? So what you folks are doing is kind of modernizing this concept in some ways, correct?
Correct. It's a different approach to creating the same concept.
Yeah.
Essentially.
Yeah. And then and for our listeners, there are people who, so there's many ways of doing clean room. So the first way is just to come to an agreement and just basically sign contracts and basically no tech, right? So,
yes.
And then I guess one other common way is to hash or add noise to the data, but that doesn't necessarily. So what's wrong with that approach?
We need to unpack it. So adding noise is very different than hashing it. So if you add noise, then by definition, you're introducing this trade-off between accuracy and privacy. Like how much noise do you want to add? And sometimes adding noise is not even defined. If you want to match names across two organizations, like what does it mean exactly to add noise? You want to match names, like it has to be accurate, or phone numbers or IDs. So adding noise is not well defined in many use cases. B, it's not a real solution because you just get a trade-off. You can work with this knob and kind of like, have it more private and less accurate, or like more accurate and less private. But you don't have this kind of like full flexibility in terms of like, I want full confidentiality and also I want full accuracy. So that's possible. And we think that, probably adding noise is not the best solution. Hashing can be useful in many cases, which is kind of like, that's one of the solutions has been used in industry, especially in advertisement when they talk about HEMs, hash email addresses. It has its own limitations, right? For example, when you're hashing data, the only way that you would have collision, if you hash two emails from two sides, the only way that you would have collision is to use the same hash function without randomness or with the shared initial randomness. And then that means that you can run all kinds of dictionary attacks, right? When you have received a hash database from the other side, even if there's an email address not in your database, you can just like hash it and see if it exists in the other set. So it's not a full solution, and hashing only works when you are dealing with like exact matches, because that's pretty much what you can do after hashing it. You cannot train an AI model over hash data. That's just simply impossible. So yeah, I would say like those approaches might have been good in the past, but I don't think that companies should rely on it at this point in time.
So another common approach, and one of the big proponents are my friends at Opaque Systems, is this hardware enclaves.
Right.
Which, I mean, it's so the advantage there is that once you're in the hardware enclave, you're basically like, you want to do machine learning, it's just as fast, right? So the disadvantage being is that if you are operating in a regulatory environment where you're really not supposed to be sharing data with someone else,
Right.
well, this hardware enclave, you're still sharing data, right?
Correct.
Yeah. So hardware enclaves are good until you're not compliant. Is that a fair?
I think it's fair. I'll add a couple of other points maybe. And one is that depends on how you want to execute your data collaboration, efforts. In secure computation, in SMPC-based approaches, essentially you have a more distributed, more equal stance in this collaboration. Whereas in enclave-based approaches, which could be very useful in certain scenarios, there's a host. There's literally a piece of hardware which has privilege, and then data gets decrypted within that environment. There could be a very good set of conversations around like, the trust model, who has access to what exactly, what is trusted, what is not trusted. And again, I'm one of the fans of like, secure enclaves. I think it's a very good technology. But then the question is that how are you going to use it, and under what conditions? When you, for example, want to do EU-US data collaboration, the assumption is that EU data should not move to US. And if you're sending your data as well as the key that is used to decrypt data within enclave, that can be unacceptable. Whereas in SMPC, you encrypt data, you hold your key, you do this collaboration over encrypted data, and then you can reconstruct the result. So there's literally no point in time that data was disclosed to the other side.
Oh, interesting. And then another more advanced approach is federated learning. If you're doing ML, and this is a term and an approach pioneered by Google, primarily because they were trying to do machine learning on edge devices, mobile devices.
Correct.
And so what's the problem with using federated learning in this kind of data clean room scenario?
Right. So just to clarify, I think there are scenarios where we are replacing federated learning, and then there are scenarios that we're complementing federated learning. As you mentioned, the reason that it was invented in the first place was for Google to kind of like do training over millions of devices in a more privacy-preserving way. And the idea was that, okay, let's bring the model, a version of the model to the devices, train it locally, and aggregate the updates. The part that we are complementary is that when you're aggregating updates, you can do it via secure computation. So essentially, even the central server doesn't see the delta between the model version 1 and 2. And then there are so many works that show how you can extract information based on the updates that you're receiving from that device. You're not receiving raw data, but you can reconstruct some information about the original personal data. So this is where we can be complementary. Like, federated learning is, I would say it's a concept, right? It's a concept of like bringing some piece of information to you. And if you can parallelize the computation, it works. And training AI and ML algorithms is parallelizable. Okay, so that makes sense. So instead of doing everything in one central point, you do a million smaller tasks, and then
or in the data collaboration setting that we're describing, it could be like a few companies updating each model and then
right.
sending the updates to a central model. But so when they send the updates, Sadegh, to the central model, how much IP and privacy are they leaking at that point without using SMPC?
Right. That's the hard part. It's very hard to quantify it. If depending on how unique the data set was or the local data, you have more influence on the update. And that's the whole point of like updating the central model. And then the problem is that you don't know exactly how much information is that. It could be minimal, it could be significant, and you are always in this dilemma. And we argue that there's no need. You can securely aggregate updates and go from model version 1 to version 2 without seeing any individual updates.
Yeah, and the other, so even if you do your kind of your ML clean room using federated learning, or you want to do it that way, so Sadegh point out there's no real guarantees about security and privacy. But secondly, it's also quite advanced, right? I don't even know if there's any tools, right?
For federated learning.
Yeah. Just for normal companies, right? So yeah, Google does it, right? So maybe Apple does it, but there's not a lot of tools for people to even kick the tires, right?
It is fair. I think it's fair. I think the tools are not as advanced as they should be. And again, I think there are many use cases where federated learning makes a lot of sense. But one thing we argue is that when you think about data collaboration more holistically, I think federated learning is one of the pieces. For example, if you want to match records, federated learning is not defined. When you want to do inference, I'm not sure if federated learning can be defined. It's useful when you have like a parallelizable task, and this concept could be applied to SQL queries. It's not related to ML. For example, if you have a SQL query which can be broken down into pieces, and you are able to run it on distributed databases and aggregate the results in order to achieve the same goal, it's a federated learning concept, right? Federated execution maybe concept. So I think that concept should be used in wherever it's possible with some umbrella of secure computation, which kind of like aggregates the updates or distributes them, or whenever federated learning is not working, you can use secure computation itself directly to run your compute.
So another approach might be, and I don't know if if I'm going to describe this properly, Sadegh, but let's say you and I want to collaborate, right? So I take my data and somehow using my data create a synthetic data set. You do the same, and then we share synthetic data sets.
Right.
Is that something that people have tried?
Oh, people have tried it, and I think there are successful startups in the space. The question I would have is that, the quality of that synthetic data depends how closely it is mimicking the distribution of the original data. And in some scenarios, it can make sense. In some other scenarios, then you end up in a trade-off again. So you are dealing with a system that if you want to have more realistic data, it's closer to your original data. And the more that it deviates, it reduces accuracy or the statistical behavior or characteristics that it had in the beginning. So you are dealing with this kind of like a trade-off. Plus the fact that, synthetic data is defined in certain scenarios when you want to kind of like provide access to a resemblance of data, which I think makes sense when you want to give feeling to how the data is to data scientists. So in my view, the way the perfect system would look like is that you have a synthetic data generator that creates a resemblance of the data, provides that access to data scientists, which, you know, any data scientist wants to kind of like play around with the data set and kind of like run some tests. That makes sense. Once you're satisfied with your you know, task, then you can run it over real data. So I think that's a kind of like a best of
Oh,
two
you
worlds.
mean if you and I are going to collaborate, before I convince you to collaborate with me, I share some synthetic data with you.
Correct. Yes. And then we run some tests. We kind of get the feeling of like, what is it that we want to do? Maybe converge on which model, or maybe it's, you know, high level, like, you know, which hyperparameters are we talking about? And then we start running that over real data, and then we can tune the hyperparameters over real data.
Interesting. So, all right. So, which brings us to what you folks do, which is secure multi-party computation, or MPC. And I'm not going to go into what that is because it's super complicated. I've attended a webinar that you folks did explaining what it is. But so here's my stab at trying to explain it in plain language, so that you can jump in and correct my description. So MPC is like a group of people trying to solve a puzzle together without revealing their individual pieces. And it's a type of cryptography that enables joint computation of a function while keeping private inputs hidden even as you collaborate.
Perfect. That's a
Perfect.
perfect definition.
And so then, with that said, at a high level, MPC then, if you can do it, can help you with data matching, right? So reports, analytics, SQL, right? Machine learning. We talked about LLMs. So, but the knock always is it's too slow. So now, which brings us to Pyte, right? So which parts of the slowness has Pyte been able to overcome? And you don't have to answer this from a technical perspective, but answer it from a use case perspective. Which of these classic data science and ML use cases are you comfortable that you can address? And you can even qualify it and say, okay, we can address this for training, but for inference, but not for training.
Right. It's a very good question. I'll even kind of like make it a little bit worse in the beginning. Aside from performance, it also had a huge usability problem. You know, with what is SMPC? SMPC is a branching cryptography where it's dealing with a handful of protocols on how you can encrypt data or create secret shares and process them without reconstructing them. So now the question is that how is that related to my Python script? You know, there's a disconnect. You know, Python script and like, you know, machine learning frameworks are such high level descriptions of what is it that you want to do that they're very far from actual secure computation protocol description. So, you know, pre-Pyte, there were like, you know, cryptographers, researchers, like including myself, where they came up with methodologies to go from like this application layer to a secure computation protocol. And the caveat was that you had to modify the protocol every time you change your task, which is kind of like unacceptable. So one of the innovations behind Pyte is something called Pyte transpiler, where it takes, you know, graphs from these standard machine learning frameworks and automatically translates it to a secure computation protocol, which is, you know, kind of like almost solves that usability problem. However, in addition, it also helps with performance. You know, there are so many ways that you can do this translation. And the optimal one is unknown as NP-complete problem in computer science. So you can come up with like better and better approaches. And what we have done the past few years is the ability to come up with like very concise descriptions of high-level tasks to secure computation protocols, in addition to all the software innovation that we have done on the networking layer and execution level to overall make this process very, very efficient. Is the overhead zero? By no means. I don't think it will ever be zero because there's a difference between processing encrypted data and processing plain text data. Now, the question is that, well, it matters how much overhead we are talking about, which is a very fair question to ask. For example, as of now, with what Pyte has today, I would say when you're training high-end LLMs, yes, it's impractical. But that's, I think it's a
but very few people do that, right? So
exactly.
most people do fine tuning or RAG, right? So
exactly, fine tuning possible. We have published blog posts. You can look at the benchmarks. Obviously, it's going to be much slower than when you use GPUs or plain text data. But I want to emphasize that what are you achieving here? What you achieve is access to the data that you didn't have access to before. If you already have access to all piece of information, good. There is no need for Pyte. In reality, there are some very high value data sets that you don't have access to, and it might take months or years for you to get access. We say that, okay, you can get access much more immediately, much faster, in exchange for a little bit higher compute overhead, which I think is a good trade-off in 95% of the use cases.
and so which means, for listeners, right? So anyone who's done fine tuning, and that's what I've been doing a lot in the last few months, you quickly realize that most of the time, most of the task is really just on the fine tuning data set, right? So the value is in the fine tuning data set. So you can imagine a scenario where you really are super protective of your fine tuning data set, and you want to collaborate with someone who's equally super protective of their fine tuning data set. But then together, you can collaborate and come up with a model in the end that benefits from both your data. But what you're saying, Sadegh, is that without actually kind of revealing any private information or any secret sauce,
Correct.
right? So, yeah. And so then once that fine-tuned model is done, you have two options, right? So you can do straight up inference, which is just a model. So it'll be as fast as the normal inference for that model. And and then I suppose you can do the kind of the much more secure inference that you described earlier,
Correct.
right? But set that aside, even the plain inference, you've already benefited from collaborating with another party, right?
Exactly. Yeah. I mean, it could be kind of like one or the other or both at the same time. So either the problem is having access to data to fine-tune the model, or the problem could be, okay, I have a model, but I don't want to be able to kind of like read prompts and read the responses. I want to do it in a black box fashion. Or maybe it's a combination of both, but it doesn't have to be both at the same time.
So like for people who live in kind of the data warehouse, data lakehouse world, right? So SQL. So what is the state of MPC or in specifically Pyte in that area? I mean,
Right.
is it fast? Is it right? So
I mean, fast is a relative term, right? Similar to the conversation that we had for ML, I think. So let me explain what we have right now. So we do have an engine which takes SQL queries and maps them to secure computation protocols. So essentially, you have literally the SQL interface. You type what is it, the query that you want to run.
So translate this more into plain language, like I have a warehouse, you have a warehouse, and then what?
Right. And then let's say in the past, let's say you have an analyst that wants to run some queries, which would consume data from two databases that you mentioned. Then the question is that, okay, so how are you going to run this? Again, for query,
With security and privacy in mind, specifically,
exactly.
right? Yeah.
I mean, one idea is that, okay, so we just like join data sets and then we run it. That's solution number one. If it's acceptable and possible, you should do that.
Yeah.
Solution number two is that it's not acceptable, but that query specifically can be parallelized. So you can run one version on database A, one version on database B, and combine the result. What is the example? The example is like, I want the average of salaries in all the people in both data sets. Okay, so these can be broken down into two pieces. Average salary of database A, average salary of database B, and then you combine the result, accurate result. Great. If you cannot do that, then you don't have much other choice, pretty much. With Pyte, what you can do is that it acts as a secure umbrella. So you start from SQL queries, it gets translated to protocol, and then the protocol is executed between these two databases without moving plain text data. So essentially, Pyte digests data from its source, encrypts it, and then talks to the other Pyte node. Can we do it for any possible SQL query? No. But for practical purposes, I think we can satisfy probably like 90% of the...
So anyone with like a classic data warehouse star schema, right? So where you have a fact table and dimensions should be
Correct.
doable there, right?
Yes. Yeah.
Because that's a simple schema.
Yes.
Yeah. So the state of MPC and Pyte for SQL, what does it rely on? Let's say I'm in the Databricks world. So do I need to integrate with Databricks Lakehouse? So what are some of the key pieces that have to be in place before I can use this technology in my warehouse?
Right. Essentially, you only need to have one Dockerized image, the Pyte node, which you can point it to your own data, and then you can point it to the other Pyte node, which you want to do collaboration with. That the other Pyte node can be in any environment. And one of the things that
And the Pyte node sits like if I have Databricks over here, Snowflake over here, so Pyte is sitting on top of the Databricks warehouse.
Correct. It sits on top of the Databricks warehouse, digests data from that environment. And the beauty of the system is that you have full interoperability. So you can work with other folks that are on different platforms. But they also have Pyte node. So for example, there are people that are using just clouds in a in the lower stack way, like just like using cloud themselves. There might be people on-prem, and you don't need to convince them to come to your platform. This can act as a bridge between where you are and where people are.
So we talked about MPC and Pyte for LLMs and generative AI, but the reality is a lot of people still do classic machine learning, right? So time series forecasting, logistic regression, and things like that. So what is the state of MPC for that workload?
That's the most mature product and use case that we can think of. Like, for example, anything that is related to decision trees, logistic regression, linear models, clustering, these are the use cases that we have actually deployed in industry. So these are, in those use cases, the interesting part is that the compute was less intensive to begin with. So when you add overhead, it's sometimes not super visible even. If your compute took 10 milliseconds and now it takes 20 milliseconds, you don't even feel the difference. But it's happening all over encrypted data. And I agree. I think the body of the industry, aside from elite tech companies or elite startups, most people are using classical machine learning models. And for them, SMPC overhead, I would say, is more than acceptable. We have never lost a use case or a company because of performance, especially for classical models.
So what's in your near-term roadmap?
We are working on a couple of different things. One is that we are working on Pyte transpiler to come up with more efficient representations for protocols and make it more usable. The set of machine learning tasks and SQL queries that we can support should be expanded. And we need to do a better job on kind of product integration points. There's Pyte concept, and then there are other systems that we are using. We do have connections for people to kind of just spin it up and use it, but it can be improved. So that's kind of on the usability and UX front, we are spending a lot of time.
What about for LLMs? What's on the roadmap for LLMs?
For LLMs, we are kind of actively thinking about what is the trend for industry. Are there going to be many players, or there would be a handful of players, and that drastically changes the product roadmap for us. So essentially, if there are so many companies that are working on custom LLMs, then the Pyte wrapper for inference would make a lot of sense. Or if there would be more demand on fine-tuning, that's a little bit separate, sort of work. But we are kind of like investigating. We are monitoring the space as we speak and building these two products in parallel.
So the endpoint is custom LLM, but custom LLM broadly defined, right? So it could be custom LLM might mean one that has been fine-tuned, but also uses a mixture of experts that includes some elements of RAG. So are you guys doing anything in the retrieval augmented generation arena?
Not as of now, but we definitely we are keeping an eye on how the space is evolving. One thing that we always need to do is to understand what are the privacy and security concerns on that front. Because we are not a ML infrastructure company. We're essentially a data collaboration company. So if the use cases are satisfied with current tools, then there is little play for Pyte. If it inherently has this problem of like aggregating data from multiple locations, then Pyte becomes more valuable.
Yeah, RAG will have that problem, obviously, because basically, I have a bunch of documents, you have a bunch of documents, we want to collaborate somehow to answer questions, through a language interface, but maybe not through a search interface where, because classic search will be, you return, here's a bunch of answers and here's the links to the source documents. Well, I may not want to reveal the source documents. I just want to answer the question, right? So,
right.
Yeah. And with that, thank you, Sadegh. And again, check out their website, pyte.ai.
Awesome. Thank you so much, Ben, for having me. Thank you, everyone who listened. If you have any feedback, if you want to get access to a better version of the product, please reach out to Sadegh at pyte.ai.